Hello students, so we are going to discuss a very important topic of current electricity, that is Wheatstone Bridge, right? Okay, so up till now in the previous videos we have discussed about Kirchhoff current law, Kirchhoff voltage law, and also we have solved the sums based on this topic, right? Now, Wheatstone Bridge, generally Wheatstone Bridge is the most frequently asked question in your CBSE board exam, even Gujarat board. Fine. Now, Wheatstone Bridge is an arrangement and it is to calculate the value of an unknown resistor. Right? So, with the help of Wheatstone Bridge, you can calculate the value of unknown resistors. Right? So, the four resistors are arranged in the form of a bridge. There is a galvanometer, right? A battery and the key. This is the circuit of a Wheatstone Bridge. Now, actually there are two cases of Wheatstone Bridge. First one is balanced Wheatstone Bridge. Second one is unbalanced Wheatstone Bridge. Right? Okay, so turn by turn we will discuss both the cases. First of all, we will go for the balanced Wheatstone Bridge. What is a balanced Wheatstone Bridge and how we are able to calculate the value of unknown resistors. Right? So first of all, the basic purpose of Wheatstone Bridge is to calculate the unknown resistors. Right? So out of four resistance which you are seeing in the diagram, three are known, one resistance is unknown. Right? Let us say R4 is unknown. You can take any of the resistance, there is no problem. Okay, so say R4 is unknown resistance. First of all, I will discuss about balanced Wheatstone Bridge. Balanced Wheatstone Bridge. Okay. So we need to calculate the resistance R4, right? Okay. So I is the current which will be coming out from the battery. It will reach at this point A. A is defined as junction. So current gets divided. Let us say I2 current goes in this direction, I1 current goes in this direction. Now, since R4 is unknown, right? One resistance will be of variable type. It will be a variable resistance whose value can be changed, whose value can be adjusted according to your requirement, right? Suppose let us say R3 is a variable resistance. So you can change the value of R3 accordingly and keep or fix the value of R3 such that potential at point B and potential at point D becomes equal. That means change the value of R3 until galvanometer shows zero deflection. Right? R4 is a resistance whose value is to be found out with the help of a Wheatstone Bridge. Wheatstone Bridge is an arrangement of four resistance, or you can have five resistance arranged in the manner of a bridge. Right? And it is to calculate the value of unknown resistance. Right? Okay. Now, let us say R4 is an unknown resistance which we need to calculate. Right? Okay. There are two cases of Wheatstone Bridge. First one is balanced and the other is unbalanced. We will discuss it turn by turn. Now, R3 is a variable resistance whose value can be changed and can be adjusted, right? That is according to your requirement. So, adjust the value of R3 such that galvanometer shows zero deflection. Galvanometer shows zero deflection, that is, it is possible only if the potential at point P and potential at point D is equal. Current will flow only when there is a potential difference, right? If the potential of point P and D are equal, the galvanometer will show zero deflection. Fine. So now, I2 is the current flowing through this resistance, will reach here. Current will not go over here. So I2 will be flowing through R4. Similarly, I1 will be flowing through this. And at point C, I1 and I2 will be combined and total I1 plus I2 current will go back to the battery. Right? Okay. Let us find out the value of R4. Take this loop. Consider loop A, B, D, A. So let us use KVL. We are moving in this direction. I have explained in the previous videos that if we are moving in the same direction as that of current, the voltage drop across resistance will be taken negative. If you are moving in the direction opposite to the flow of current, the drop will be considered positive. So starting from A. So it is current is in this direction, we are also moving in the same direction. So minus I to R2, right? There is no current in this branch, right? In this galvanometer, and we will be moving in this side. I1 is current moving in opposite side. So it is plus I1 R1, that is equals to 0. So it is finally I1 R1 equals to I2 R2. Therefore, I1 by I2 is equals to R2 by R1. Right? Similarly, let us take another loop B, C, D, B. Right? B, C, D, B. Let us start from point B. So minus I2 R4, because we are moving in the same direction as that of current. It will be plus I1 R3, that is equals to 0. So I2 R4 equals to I1 R3. So again, I1 by I2 will be equals to R4 by R3. Right? So say this as equation number 1. So this as equation number 2. Left hand side is same. So if we compare right hand side, it will be R2 by R1 is equals to R4 by R3. That is R1 by R2 equals to R3 by R4. So this is the condition of a balanced Wheatstone bridge. Right? You can understand this in an either manner also, that if the bridge is balanced, that is if R1 by R2 is equals to R3 by R4, then galvanometer will not show any deflection. Right? This is also an alternate way to understand this. So now we need to calculate R4. Since R1, R2 and R3 are known to you, you can calculate R4. This is how Wheatstone bridge is to calculate the value of unknown resistance, right? We will solve the examples based on Wheatstone bridge, so we get a correct idea how to find out the equivalent resistance. This was all about your balanced Wheatstone bridge. In many of the questions, they will be giving the resistance over here, so it as R5. The first thing is that you have to check whether the ratio R1 by R2 is equals to R3 by R4. Like suppose if I am taking this value as 10, this value as 5, right? This value as 20, and this value as 10. So check this whether 10 R1 by R2 is R3 by R4, 10 by 5, 2, 20 by 10, 2, yes. So the condition is satisfied. So this bridge is known as a balanced Wheatstone bridge, right? So that means potential at B and D are same. So current will not flow through R5. So it will behave as open circuit, because resistance are to oppose the flow of current. If there is no current flowing, resistors are useless, right? So the circuit, this part of the circuit will behave as an open circuit. Right, then these two resistors will be counted in series, this two will be counted in series, and finally both will be in parallel. Right, this is how we will solve the sums based on balanced Wheatstone bridge. We will see one more example, right, about balanced Wheatstone bridge, and then we will find the equivalent resistance for an unbalanced Wheatstone bridge. Right, unbalanced Wheatstone bridge means if R1 by R2 is not equals to R3 by R4. If this is the condition, that means in bridge the four resistors are not balanced, then you cannot neglect this resistance. You need to count, because if R1 by R2 is not equals to R3 by R4, then automatically potential at B and D will not be equal. Potential at B and D will not be equal. Right? So then current can flow through this branch, so you cannot avoid this resistance. Right? It will be more clear after solving few questions. And second thing, when R1 by R2 is equals to R3 by R4, that is when bridge is balanced. In this case, if you are changing the position of galvanometer and cell, then also there will be no deflection. Right? There will be no deflection of galvanometer if you are changing the position of galvanometer in the cell. Only when the bridge is balanced. Right? So this is all about your balanced Wheatstone bridge. We'll discuss few examples on balanced and unbalanced Wheatstone. So look at this diagram. This is an application of Wheatstone bridge. There are 10 resistors, each of value R. We have to find equivalent resistance between A and B. Right? All the resistors are having the value R. See, from the diagram you can see that we can think of two different Wheatstone bridge, right? In Wheatstone bridge, we were having total of 4 resistors and 1 galvanometer, and I have explained you that instead of galvanometer, there can be a resistor also, right? So in a single Wheatstone bridge, there are 5 resistors, right? So think about 2 Wheatstone bridge, upper half and lower, that is R1 by R2 is equals to R3 by R4, right? So that means these 2 points are having same potential, so this resistance can be removed. Similarly, the lower half, R1 by R2 is equals to R3 by R4. So again, these 2 points will be having same potential, so this resistance will be taken. So now the circuit gets simpler, right? And these 2 resistance will be in series, so it will be 2R. This 2 will be in series, you can break the circuit also. These 2 are in series, so it will be 2R, 2R, 2R in parallel. So getting the point, R series, that is 2R, R series, 2R, 2R, 2R parallel, R. Similarly here, R 2R, 2R will be again in parallel. So now it will be again 2 resistance of the value R and R will be in parallel. So our answer is R by 2. Right? So this was a sum based on a balanced Wheatstone bridge. Let us see one more sum on balanced Wheatstone. Let us see how to solve this sum. So there are 5 resistors. Actually, if there are 5 resistors given in the circuit, you can always think of Wheatstone bridge first. Right? There are 5 resistors, 2, 4, 10, 4, 8. We will find the equivalent resistance between A and B. See how to solve these sums. First of all, you can mark the points, or you can mark the number, no problem. 1, 2, 3, 4. Right? First of all, mark the number 1, 2, 3, 4 at the end of the wire. Now, you can write A and 1 from same point, right? Because there is no division between these 2 points. So starting from A, or you can say 1, there are 2 ways, there are 2 different paths possible from 1. One is directly going from 4 ohm resistance to point 3. Once again, we'll start with this point 1. There are 2 possible paths. One directly going to 4 ohm resistance and it will reach at point 3. Another route is going to point 2 via 2 ohm resistance, and there from point 2 you can go to point 4. Clear? It should not be confusing. See, from point 1, there are 2 different paths possible. One you can go directly to point 2 and then from there to point 4. Or else you can go from 1 to point 3 and 3 to 4. Right? So, we'll go in both the ways, one after another. We'll go from 1 to 3. First we'll go in this route. 1, 2, 3 and 3 to 4. So 1, 2, 3. Point 3, right? Starting from 1, going to point 3, there is a 4 ohm resistor. 4. From 3 to 4, there is 8 ohm resistance. Point 4, 8, right? Then the second route, again we'll start from 1, we'll go to 2. And there is a 2 ohm resistance. Right? And 2 ohm resistance. From 2 we can move to point 4, and there is a 4 ohm resistance. Right? Now there is a resistance of 10 ohm between 2 and 3. This is point 2, this is point 3. So as you can see, R1 by R2 is equals to R3 by R4. First of all, check whether the bridge is balanced or not. So that is 2 by 4 is equals to 4 by 8. Definitely yes. That means the condition of balanced Wheatstone bridge is satisfied. That means point 2 and 3 are having same potential. So this 10 ohm resistance will be taken away. So now 4 and 8 will be in series because whatever current goes through 4 ohm, that has to pass through 8 ohm. So current remains same in series. So this 2 will be in series. So your answer will be 12. Similarly, this 2 will be in series. So your answer will be 6. And then finally 12 and 6 will be in parallel. So R equivalent will be 12 into 6 by 12 plus 6. So that is 72 by 18. Answer is 4 ohm. So this is how we will solve the sums based on Wheatstone bridge, balanced Wheatstone bridge. Right now, in the next video, we'll discuss two methods of solving unbalanced Wheatstone bridge. What if the ratio is not balanced? Then the middle resistance will not be neglected. Then how to find the equivalent resistance? This we will see with the help of KVL, and also we will see by using delta to star conversion. Right?